Hello and welcome to our Covestro Home Office Talk. All live, as always. We do a live interview and answer your live questions, which you could send us from your desktop or mobile device. And now let me introduce our today's topic, going circular with climate gas CO2. It's Monday, the beginning of a week with important next steps. We've just learned that European Union might raise its target for CO2 emissions cut until 2030. Good question, though, how we could get there as consumers and as industry. Sustainable carbon capture utilization, very complicated, short CCU, might be one measure to reduce the climate gas CO2 and to broaden the raw material base. So my first question to you out there would be, do you have any good usage of CO2 so far? What would you do with CO2, actually? Just let us know in the commentaries below here. But coming now to our two guests today, that certainly they have very good ideas about using CO2. So please let me welcome our guests. Professor Kurt Wagemann, chemist by heart, entrepreneur and managing director of DECHEMA. Live from Frankfurt today, beautiful office on the River Main. DECHEMA is the expert network for chemical engineering and biotechnology in Germany. The non-profit professional society counts more than 5,800 members. And also welcome to Jochen Norwig. So, Dr. Jochen Norwig, Senior Project Manager for CO2 Research at the famous Catalysis and Technical Incubation team of Covestro. Also very complicated. But live from your home office close to Leverkusen. With your work, Jochen, you are actively contributing to solve the most urgent questions of our time. So let's dive into the first question live as always. And of course, you at home, you can always put your commentaries and questions to our experts in the field below here. So we will answer them right away, be sure. So CO2 technology, what can we achieve at the moment, Kurt and Jochen? So what's the status actually?
Should I start?
Please, Kurt.
First of all, thank you very much for this very kind introduction, Petra. In principle, we have three options to defossilize the chemical industry. I usually do not use the term decarbonization because we need the carbon. But in principle, these three options are the use of biomass, the recycling of waste, especially polymers, and the utilization of CO2, combining it with renewable hydrogen. And that's the idea behind the CCU term. Use CO2 and convert it as direct as possible into chemicals. And what we need is hydrogen, green hydrogen, made by electrolysis of water using electricity from renewable sources. These are the three options, and I'm pretty sure that the most important one is that the CCU.
Mm-hmm. Jochen, what do you think live from Leverkusen at this point of time and this Monday lunchtime?
Yeah, I mean, completely correct. So this is the great overview. And now if we just zoom it a bit, then for the utilization, with regard to the utilization of carbon dioxide, the direct utilization of carbon dioxide is just one step before the utilization together with hydrogen. And this utilization of carbon dioxide is something which we at Covestro have been dealing with for now about 12 years. So it's a quite long process towards from research to go to really the market with final products. So we've done this starting with a kind of a dream reaction, where at a time where everybody said, well, okay, I mean, carbon dioxide is an end product, thermodynamically, in a way, a dead horse. And you want to ride this dead horse? I mean, come on. So, but some people at Covestro and at other institutes and in industry just tried to ride it, and they got this horse really alive in the end. But this was quite a strenuous, long way of research and development. Now, in the end,
Jochen, could you maybe explain to our viewers a little bit the, just very briefly, dream reaction? So why was it a dream, actually? What is so difficult about it to utilize CO2?
Yeah, the dream is to have this end product of combustion processes, so which combustion processes, but as well biological processes. So typically carbon dioxide is something which is, at least in industry, not used anymore. There are some processes, or have already been some processes before, yeah, but they were really niches. So the dream was to have this product with very low energy, so it's not really reactive. To get this product reacting in a, in our case, polymerization reaction to make up a new material. And yeah, this was then the endeavor we went for, and well, okay, this was what we tried to do. So as I said, thermodynamically, a really dead horse, so hard to push it to reaction. You need the right catalyst to do this. This was the first thing which was then invented / discovered in order to really make a technical process of it. When the principal reactions were already there in so something like 50 years ago. But these principal reactions in research don't help much as long as you get, say, 1 gram per day or so, or at least 1 kilogram per day. Then you can't make up a real material. You need a really active catalyst to lower the energy which is needed to activate. Can you see it? Yeah, to activate the carbon dioxide molecule to be built in rigidly, so covalently. And to capture it into a new molecule, which in our case is a polymer. So this was the dream we had, and so others had. I didn't believe in it at that time, so it took a while until I did, yeah.
Kurt, watching the industry closely as you are really managing a big network of different industry players. So, yeah, what do you see at this moment? So, what is possible right now?
Everything is possible. It's only a question to start, and congratulations to Covestro that you started 10 years ago and were successful, and that's important to demonstrate that it's possible. At the end, the complete defossilization of the chemical industry, it's possible. The processes are available. They must be better, that's clear. There must be a close interaction between industry and academia and within the industry. And it will cost, that's clear. We must find ways how to finance this transition. But for me, it's presently the most important activity is to bring together the partners along the value chain, and to bring together the partners on one side from industry and on the other side from the academia in large projects like as we do right now, funded by the Federal Ministry for Education and Research, the Copernicus project on Power to X, where we have a lot of partners, more than 50. Covestro is one of them. There are other chemical companies, but there are also companies like, for example, Siemens on one side related to electrolysis, And on the other end of the value chain, we also have a company which produces cosmetics like Beiersdorf. What I think is important to demonstrate that it's possible, and not only for your own subject or your own part of the value chain, but the chain as a whole.
Just a short message to our viewers out there. So if you have questions in regard to CO2 usage or CCU or whatever can be done in regard of new raw materials, please let us know. Please put your questions down here in the commentaries field and we will answer them right away out there. But Jochen, back to the topic. So what do you see? So what was really developed in the last 10 years? So what is the real product range we can already see and touch out of this new range of raw materials we have there with CO2?
Yeah, we have a brand name for the first products, which are so-called polyols. So again, raw materials for further polymers such as polyurethanes. So that's Cardion. So on this Cardion you can use, for example, as raw material for flexible foams, which then are used in well, mattresses, for example. So you can sleep on carbon dioxide, not the gaseous one, but really tightly bound into the molecules, so really part of the molecular backbone there. Other applications are other kinds of flexible foams which you use in the inner of cars, or a completely different kind of application is the utilization of this Cardion in binders, which are used in order to aggregate and bind sports floors for example, hockey fields, so field hockey fields, which consist of a certain kind of granulate underfloor, and this granulate is bound there and tightened by means of a binder made of carbon dioxide. There are other, say, products. A thermoplastic polyurethane has been released already to the market. Other products such as elastic fibers made of this thermoplastic polyurethane are well just about to be industrialized, but not yet in the market. And there's a well broad pipeline which we have filled with a couple of other products which we can make, or which you can make, others can make from, well, say, derivatives of this Cardion. Products now at different stages of research and development, some already quite mature, others rather in earlier research, so with a quite long way to go. But the good point about it is that with Cardion and with the underlying CO2 technology, we really have a broad platform for a vast variety of products which we can use there in order to really set a good starting point or anchor point for other activities.
We've just seen that during you were talking, we've seen some great examples, some pictures of really using this new polyol in producing soft foams for sports floor, for example, or textile fibers, which is really revolutionary. Kurt, what do you think? Is this kind of new approach to industrial production, could that really save climate in the end? So what is your prospect to this whole development?
I will come back on this question in 1 minute. Just I would like to make a comment on what Jochen just said. I think this material is what makes it interesting, and why I think there's a chance for a real big success story is that this polyol, it's not just a replacement. It allows for developing new properties and new applications. And some information I received during the last months is that there are new possible partners for your company who are interested in the material because of new properties. I think that's important. And Jochen used the term platform. I think that's also very important to have a platform technology which allows for different applications. But now, finally, I come back to your question, Petra, on the option saving the climate. At the end, such technologies will help to save the climate. Presently, we must be honest, the amount of CO2 used in the chemical industry, including these new activities of Covestro, that's not very much. It's a very small percentage. It won't change the climate to the positive development. But when we go further and think about maybe the year 2030, but I personally think, and that is part of our analyzing activities at DECHEMA, very probably it will be starting really in the year 2040 plus, where the chemical industry will really make progress and have a high percentage of its products produced from CO2 and not anymore from petroleum. And in addition, it's not only the chemical industry at that time, beyond 2040, it will be also the fuel sector, which will very much rely on the CCU technologies. So it's important to start and to demonstrate that it's possible, and producing materials, chemicals, which can be used nowadays, but the final goal for complete defossilization, that will be in the future, maybe 2030, 2040, and then it will be part of our way to save the climate.
At this point, to our viewers out there, please let us know, do you have any idea of usage of CO2? So what is your idea in really coping with the climate crisis in regard to using new raw materials and having new applications in industry and having a change? So, but overall, we could come now. We have some questions in already, so thank you really very much. It would be great to go now for the first question and really have it answered. So this is coming from Scott. So Scott is asking, circular is being used in every industry. Can chemical recycling and carbon capture fit into a circular model? This is from Scott. Thank you, Scott, for your question. So to Jochen and Kurt.
Yeah, I'm convinced that this is possible. In fact, we are doing this. So if you think about carbon dioxide as an end product of many products, so material lives, then you see, well, okay, then it's well down to grave when we use it again as a cradle. So we really close this circuit and then have really a kind of circular economy. Of course, it's not a complete closure of it, and not all of the carbon dioxide is now put into this circle, but it's at least a contribution to a circular economy with this. So I think, yes, it is possible to increase the degree of circularity by the utilization of carbon dioxide on the one hand side, but of course by the utilization of recycled material CO2, which you put in then, not necessarily as carbon dioxide, but as other building blocks. And then you might have even an input from, say, biogenic materials there. So you have, in the end, a renewable kind of renewable circularity there.
This is the big picture Jochen is describing, and that will be the final goal. When we talk about chemical recycling, then it could be also to break down the polymers, for example, into the building blocks and use those again. This is what I mentioned at the beginning, that there are in principle three options: the biomass, the CCU, and in addition the chemical recycling of organic materials, especially polymers. And I think it's very important also to work on this. It's also a circle which can be established, and I think that will be a very important option with increasing importance during the next years, as I see there are many chemical companies working on that subject.
Let's come now to the second question. So let's show this one coming in from Alexander. So Alexander is asking you, Kurt, dear Professor Wagemann, you talked about the costs of inventions. How could you describe the political will to shape the markets fitting to the challenges? So more heading to the political direction of possibilities.
Yeah, that's very important because presently, when we produce chemicals or fuels on the basis of CO2 and hydrogen, it's a factor of 2, 3, 4 more expensive. So there must be a way how to overcome the economic hurdles. Everybody talks about the price of CO2. That's clear. That would be the final solution. I always think in terms of different steps, increasing the share of renewable products. And there it could help a lot as a starting point to have something similar to the fuels directive, where 5% of the fuels must be based on biomass, the biofuels directive. It would be useful to have something similar for CCU products. I'm very much in favor of this idea, to start the process, to have more companies working on the subject, and to produce higher amounts and get economy of scale. That's very important.
Thank you. There's a third question, really interesting one, ready to be shown now, coming in by Avais. What is the simplest technique to capture CO2 and utilize it on the industrial level? So a bit more to the technical possibilities here. Jochen and Kurt.
Yeah, the ideal is, of course, if you have the CO2 in a very clean state already from another process. So this is something where there are sources out there in industry where you really produce carbon dioxide as usually off gas or as process gas. And if you use these sources first, then it's quite easy. You don't need to capture it, because in order to capture it from, for example, from the air, which is done too, then you need some effort to do this. You need energy to do this. You need to separate the carbon dioxide from the rest of the gases. So 0.4%, yeah, from the rest of nitrogen, oxygen, and what's there, argon. Yeah, that's always quite an effort. Good if you have other sources. These sources have been studied in detail in the course of the last, I don't know, 5 to 10 years. I can't give the exact dates, but from that we know that there are, for the time being, sufficient sources with rather clean carbon dioxide.
Mm-hmm. Okay. Yeah.
Maybe I could add on this. That's completely correct, and is the present status to use sources which are, let's say, clean with a high percentage of CO2. For example, also from the chemical industry itself, like the ethylene oxide process. But when we need higher amounts because you are successful, then we have to find options how to use other process gases, off gases. Not so much the exhaust gases from coal-fired plants, power plants. They will run out. But we have other CO2 sources like from the production of cementum or the steel industry. And we will need these sources in addition to, for example, the CO2 from bio processes like the production of bioethanol or biogas. And finally, also the utilization of the CO2 from the atmosphere, the direct air capture is an option, but presently we are also in favor of the so-called point sources of CO2.
Mm-hmm. There's a next question coming in, also really interesting. This is directly to Jochen this time. So where has Cardion been employed to date? And where is this sports field shown in the video we've just seen? Is there more than one?
Yeah, okay. The sports field in the video is in Krefeld. It's a field hockey field there. Cardion is employed. What was the first part of the question? Cardion in principle is employed.
Where in principle, right.
Thank you.
Yeah.
Yes, okay. As I said,
in which applications?
Already in the industry who produces flexible foam for mattresses. So this is done. In these binders, this is done. And the production of thermoplastic polyurethane is done as well and commercialized. So these are the 3, say, major products which are out in the market today.
A next question coming in, so we could show here, coming in by Ravi. Considering that the energy industry puts out CO2 by the billions of tons and chemicals are consumed at best in a few million tons, can CO2 capture for chemicals be a realistic solution to the problem of climate change? Would it not be better to focus on carbon sequestration into geological structures instead? Well, this is something we discussed before, but really interesting question to Kurt and Jochen.
Maybe this time I could start. It's an old discussion. What's best, CCU and CCS? And last year, a position paper from Acatech was published where I, together with other colleagues, were invited to contribute and discuss about CCU versus CCS. And I repeat what I always say, it's no contradiction. We need both. Both can use the same infrastructure, the absorption of CO2 from off gases the infrastructure which is necessary for both for the transport. And I think the advantage of CCU is to make useful and valuable products out of that, and not just to store it in the underground. But with respect to large amount, CCS has its usefulness. We need both. And I always talk about the production of chemicals and fuels, but because I'm completely convinced that also in the future we will need liquid energy carriers like hydrocarbons, and how to make them in the future when we don't use any more fossil resources. That will be also CCU, which provides the fuels. Therefore, both chemicals and fuels, you have to sum them up. And in addition, as I said already, there shouldn't be a discussion about this or that. That is both which we need.
Wonderful. We have some questions coming in, so this is really great. Thank you for the viewers out there. There's some more to come. So Jochen, maybe you can also take for the next one. So coming by Michael, CO2 is used daily by plants to build very complex molecules. Without high pressure or temperature, how far is the chemical industry away from copying and then improving these reaction paths? Super interesting, looking into the future.
Yeah, that's subject to quite a lot of research activities, in fact. So this is being done, and some catalyzed processes really work in a way that you can produce either photocatalytically or with other means of homogeneous catalysis, typically, sometimes even heterogeneous catalysis, to really utilize carbon dioxide. The trouble to date is that typically the conversion rates, so the amount of new material which can be produced per time unit is rather low, so is not in a way that can be really used for economic purposes. And so I'm afraid there will be some more research and development work on our way to really these processes. But it's really interesting and sometimes really intriguing to look at these developments there. How
do you judge this, Kurt, looking into
I completely agree with Jochen. It's a very interesting research subject, but presently quite far away from direct application, but it's necessary to work on that. That would be a real dream process.
Next question coming by Mr. or Mrs. Min. So going to Jochen, as Dr. Norwig mentioned at the beginning, these projects can take up to 12 years from ideation to end product releasing to the market. What motivates you and your team in the daily work? Good question as well.
Yeah, really the goal or the vision we have then to, in the end, have really a product in the market which is produced from carbon dioxide. And true, this is a long-term commitment there with lots of what's it called? So yeah, sometimes just have impediments there. Which with some frustration in between, and not always easy to keep on going there. But it's something which is just a great feeling in a way. So to see that in the end you really have this kind of dream reaction, which started as a dream reaction, then in the end as product in the market.
Wonderful. Coming to our last question for today. Really great one for closing. So molecular separation of CO2 from non-clean sources is a very interesting approach. Do you already utilize it in your process or consider it?
For the time being, that's not necessary simply. So we can really focus on our process and what's happening after it. So upstream, as it's called, the sourcing of carbon dioxide at the moment is still available at cleanest degrees of purity. Then that it's not necessary for us to have a closer look into this kind of new sources.
Mm-hmm. Kurt, what do you see in the industry?
I can comment on that. It's, of course, Jochen knows best about his sources, and it's companies like Linde Air Liquide method. They provide the CO2 in a very clean, high purity. Most sources are natural sources where the CO2 presently is coming from. But there's an important project on the utilization of the off gases from the steel industry. It's the carbon to chem project. And a high part of the research activities are devoted how to clean up these off gases so that it's possible to make catalytic processes with this kind of CO2. And this is a very, very important and difficult subject.
That's true. And it's even quite interesting that we do not only look there at carbon dioxide, but as well on other parts of these gases, such as carbon monoxide. So they are there, and so why not use them? Yes, that's true.
And might that be successful one day? So what is your guess here right now from scientific point of view?
Well, there are first successes there, and okay, that's something which I'm not sure how far it is published. So I can't go into detail here. But yes, the project itself, Carbon for PUR, is already quite successful.
For your last words for these great live session and talks today, so Kurt and Jochen, looking into the future, what would be your wish in next steps of development? What is your desired outcome, let's say, in the next 2 years for the topic of CO2 utilization?
Maybe I can start. I'm one of the 3 coordinators of the Copernicus project Power to X, and I very much hope that we are now in the second stage, and I very much hope that we are successful, all looking at the different options where we are working on. One is, for example, the cooperation between Siemens and Covestro on the utilization of gas electrodes. Another is the direct electrolysis of CO2, the co-electrolysis, and producing products from the CO and the synthesis gas from that. And there's another work package which is the container solution, to have everything which is necessary for such a process in one container, starting with the direct air capture, the co-electrolysis, and the conversion to fuels. I very much hope that in the next step we will have demonstration projects on that. And as always, I mention what's very important is the cooperation, not only between the academia, but among industries, among companies from different sectors. And that is what we try to strengthen, this network of companies who believe in CCU.
Last words to you, Jochen.
Oh, yeah. To me, it's really concretely the hope that we can percolate new products along the value chain. So we produce new raw materials based on carbon dioxide, and they have to be approved by each and every part of a value chain. So we want to really percolate through this value chain to the end consumer, that we have really a broad spectrum of products in the end, which are offered to the end consumer and really used there.
Wonderful. Thank you so much. Thank you very much to Kurt Wagemann of DECHEMA and Jochen Norwig of Covestro in contributing to our CO2 session today. And thank you out there to the viewers for your contribution and your interest and your great questions. So this was volume number 16 of Covestro Home Office Talks, live as always. And please tune into our next live talk, which is already tomorrow, by the way, Tuesday, 1:15 German time, in German language, next time, on green energy with Ørsted CEO Martin Neubert and Covestro CTO Klaus Schäfer. So hope to see you there. Have a great Monday and bye-bye.
Thank you.
Bye-bye.
Bye-bye.